Okay, today we're going to be looking at lesson 3-2, segments and midpoints. Today's learning target is I can determine the length of a segment and find a midpoint. For finding the length of the segment, we're going to use the segment addition postulate. For finding the midpoint, we're going to use our midpoint formula. So recall, yesterday's lesson we looked at geometric terms like line, point, ray, plane, etc. Just know that AB is a line segment with endpoints A and B. So basically, I'm starting at A and ending at B. So if I wanted to, I can draw like a visual to look like this. I have line segment A, B. Now, segment addition postulate. If B is between A and C, then AB plus BC equals AC. So I'm going to draw a segment. So I'm going to draw B is between A and C. So I'm going to draw a line segment with endpoints A and C. I'm just going to put my B anywhere. It doesn't matter where. I can say that AB plus BC is equal to AC. So for instance, if I have a 3, a 5, I can say the length of my whole segment's 8. Okay, question number 1. Find the length of segment AB. Well, if you look, you know the length of your whole segment is 10, and you know the part of your segment is 7. I want to find this missing piece right here, or X. So if I wanted to use segment addition, I could say X plus 7 equals 10. So I have X plus 7 equals 10. How do I get rid of that 7? I subtract it, and I get X is equal to 3. And that's my final answer. So I can say that AB is 3. Number 2, given DF equals 37, what is the length of EF? So if you look, I know that my whole segment is 37. So if I wanted to, I can set up an equation to be 5a plus 2 plus 4a minus 1 equals 37. Now what we're going to do is we're going to combine our like terms. So I'm going to combine my 5a and my 4a, which is 9a. 2 minus 1 is 1, so I have 9a plus 1 equals 37. How do I get rid of my 1? I subtract it, so I subtract 1, I get 9a equals 36. Then divide by 9, and I get a is equal to 4. Now if we look though, the question's asking you to find the length of segment EF. So I'm going to make this a little tinier, that way I have more room. And I go to EF and I plug in 4 for A. So EF is equal to 4a minus 1, and we know a is 4, so I have 4 times 4 minus 1. 4 times 4 is 16, 16 minus 1 is 15. So I can say EF is 15 units long. Number 3, B is between A and C. Let's just draw that out. So I have line segment A going to C, and we know B is between them. We know AB is 2 times x plus 1. We know BC is 3x plus 1. And we know our whole is 4x plus 8. So what we're going to do is we're going to do 2 times x plus 1 plus 3x plus 1 equals 4x plus 8. So this plus this equals that. So I have 2 times x plus 1 plus 3x plus 1 equals 4x plus 8. I've got parentheses, so I have to distribute. So I have 2x plus 2 plus 3x plus 1 equals 4x plus 8. I combine my like terms. 2x and 3x is 5x. 2 plus 1 is 3. And that's equal to 4x plus 8. I need to get my 4x to the left-hand side of my equation. Subtract 4x, subtract 4x. So I get x plus 3 equals 8. And then I subtract 3. So I get x is equal to 5. So now I want to find out what AC is. So I'm going to go into AC and substitute 5 for x. So I do 4 times 5 plus 8, which gives me 28. So I can say AC is 28. Midpoints and bisectors. They divide a segment into 2 congruent segments. So basically, they are the exact same length. So example, given Q is the midpoint of PR. So let's draw out PR. and it looks halfway. Determine the length of PR when PQ is 2x plus 7 and QR is 3 times x plus 1. Well, we know that Q is a midpoint, so we can say that these two segments are congruent to each other. So I say PQ is congruent to QR. So I can do 2x plus 7 equals 3 times x plus 1. I have parentheses, so I'm going to distribute. So I have 3 times x plus 3 times 1. So I have 2x plus 7 equals 3x plus 3. Subtract 2x. I get 7 equals x plus 3. Subtract 3, subtract 3. I get x is equal to 4. So now that x is equal to 4, I want to find the length of PR. So I simply just substitute. So I know x is 4, so I have 2 times 4 plus 7. 2 times 4 is 8. 8 plus 7 is 15. But the thing is, I know PQ and QR are congruent, so QR is also 15. So 15 plus 15 is 30. So I can say PR is 30. And that's my final answer. The midpoint formula. The midpoint formula is very, very fancy. We write it with a capital letter M and say it's equal to x1 plus x2 over 2, y1 plus y2 over 2. So it looks similar to the slope formula, except you're adding your x's, adding your y's, and dividing both by 2. So for this example, we're going to determine the midpoint of each of the following pairs of points. So what I like to do is I like to do xy, xy. So all we're doing is we rewrite our formula. So x1 plus x2 over 2, y1 plus y2 over 2. So now that I have my formula written, I can substitute my values. So I know my x values are 3 and negative 1. So I have 3 plus negative 1 divided by 2. And I know my y values are 1 and negative 2. So I have 1 plus negative 2 all divided by 2. Well, we know 3 plus negative 1 is 2. 2 divided by 2 is 1. We know 1 plus negative 2 is negative 1. Negative 1 divided by 2 is negative 1/2, or negative 0.5. I like to leave things as fractions. So that's the midpoint of that line segment. Now let's try to do the next one. So I use the exact same formula, x1 plus x2 over 2, y1 plus y2 over 2. So I identify my x's and my y's. So m is equal to, I have negative 1, 0, and 4, 2. So I do negative 1 plus 4 all over 2. And then I do 0 plus 2 all over 2. Negative 1 plus 4 is 3. 3 divided by 2 is 1.5. We're just going to leave it as 3 over 2. And then 0 plus 2 is 2. 2 divided by 2 is 1. So my midpoint for this line segment is 3/2 and 1. And that's it for today. If you have any questions, email myself or Ms. Calarunto.